Today we want to talk about the solving triangles game. I want to give you an overview of what the solving triangles game is all about. And we're going to work on some strategies for solving triangles. In trigonometry, most of the problems are going to center around solving triangles. Most of the applications that we're going to see are going to center around solving triangles. Most of the applications that we see will center around solving triangles. So let's talk about what a triangle is and what it means to solve a triangle, because it's really weird to use solve in this scenario. Because we use solve as just like a verb for answer math questions. It's not really appropriate. Solve is something that we can apply to equations, and apparently we can apply to triangles as well. But if I asked you to say, if I ask what is 2 plus 3, I wouldn't be saying solve the expression. I'd just be saying simplify the expression or evaluate the expression, right? It doesn't make sense to say solve because there's no equals. But that's just being overly pedantic. And that only comes up because we say solving triangles. So let's talk about what a triangle is. There are 6 parts in a triangle. A triangle has 6 parts. Three sides and 3 angles. I don't know what the appropriate punctuation is here. Even though we name it after the 3 angles, we always list the 3 sides as the defining characteristic of a triangle. So the triangle has 6 parts, 3 sides and 3 angles. The solving triangles game is that I give you 3 of the parts and you find the other 3 parts. So the solving triangles game is given 3, find 3. That's the sum total of the solving triangles game. There are 6 parts. If I tell you 3 of them, you can find the other 3. Of the 3 given pieces of information, one of them has to be a side. So of the given 3, one side must be given. I can't just give you 3 angles. But that's the game. I give you 3 pieces of information. 1 side and 2 angles, 2 sides and 1 angle, or 3 sides. I can ask you to find the other 3 parts. This raises a question: why doesn't the game work with 3 angles? How come you can't take 3 angles and find what the sides are? That's not a question that I want answered right now. You might know the answer to that question. This is a question that I want you to think about while we talk about the solving triangles game. The first version of this game that we're going to play is solving right triangle. I'm going to give you one of the pieces of information is that there is a right angle. So there are two versions of the game. The one we're going to start with is solving right triangles. Then the other one, of course, removes the thing that we had. Solving oblique triangles. That's for later. Oblique is a word that just means not right. In this context, that just means it's not a right triangle. You aren't given a right angle. Oblique just means non-right triangle. In the solving right triangles game, that just means one of the pieces of information that you're given is a 90-degree angle. In the solving right triangles game, that just means one of the pieces of information that you're given, one of the parts, is a 90-degree angle. And then I have to give you two other parts for a total of 3 parts given. And then I can actually find the other 3 parts. We have many tools to accomplish this task, to find those 3 pieces of information. We have lots of tools available to us. First, the sum of the angles is 180 degrees. Second, if we have a right triangle, we have more tools available. We don't have all the oblique tools that we need. But for right triangles, we have additional tools. We got the Pythagorean theorem, and we've got sine, cosine, and tangent. There are the tools that we could use for oblique triangles, but we don't know them yet. We don't know these yet, but they're called the law of cosines and the law of sine. How's everybody okay? Everybody looks what I would call hella stoked. Because you all look like this. That's stoked modulo math class. There's a lower scale for happiness when you're in a math class versus just like out in the world. You know what I mean? So like, is everybody happy? No. Is everybody math happy? Yeah. Math happy just means like, oh, the math seems pretty simple. I think I could do this later on. All right. Let's make some conventional stuff. So I want to set up some conventions that we'll have in a right triangle. So we're playing the solving right triangles game. So that means one of the pieces of information that you're given is a right angle. Opposite the right angle is going to be the hypotenuse that will always be C. That's normal. That's what you all do anyway. When I said what's the Pythagorean theorem, everybody was like a squared plus b squared equals c squared. And that requires that we all agree to use C as a hypotenuse. So the hypotenuse will always be C. That's a lowercase c, although I'm writing it so you can't really tell, but I assure you it is a lowercase c. It's also italicized, but I mean, that's not something that I can express in my writing. I've got to give names to the two acute angles. So far, all of our problems have only just had one angle. We called it theta the whole time. But now I want to distinguish, I want to recognize that there are two acute angles, and we might have to find both of them. So I am going to refer to one of them as alpha and the other one as beta. I'm going to give Greek names to the two acute angles. So one of the acute angles is going to be alpha. That's the way that I draw an alpha. I start on the upper right side, and I just kind of like make an X, but have it all connected. Just kind of make a loop like that. It's like making an X, but be lazy and don't lift up your pen. Put it down and then up. And don't make it angular. I'd probably flatten it out a little more, but that's how I draw. I'm going to associate alpha with one of the sides. I'm going to refer to the side opposite alpha as side A. So we're going to have angle alpha will be opposite side A. Alpha is an A is an A, they go together as an opposing pair. Alpha and A will be opposite each other. The other acute angle I will name beta. And beta will be opposite side B. Alpha is opposite A, beta is opposite B, C is the hypotenuse. So I'll use A, B, and C for the sides. I'll use alpha and beta for the acute angles. How's everybody okay? We're just naming parts, setting up standards that we can all agree to. I guess we're not all agreeing to them. I'm kind of agreeing to them for you. So we can all vote on it. Each of you gets 1 vote, and I get 52 votes. So one of the givens is going to be a right angle. Then I have to give you two of the other parts. We're solving a right triangle, so one of the things given is the right angle. I have to give you 2 other parts. I can give you 2 sides out of the 3. I can give you 1 side and 1 angle. I can't give you 2 angles because, like I said, 1 side must be given. People? Pretty soon you're going to have a homework assignment and it's going to have a bunch of word problems on it. And you're going to go, oh, I don't like word problems. It doesn't matter. All the word problems are just this. Somewhere in the word problems is just a right triangle. Look for the right triangle, and then you can take the word problem out of the problem. You just have a regular problem. Translate your problem into a right triangle, and then it's no longer a word problem. You don't get to be all, I don't like word problems. Also, it's crazy to not like word problems, because in word problems, theoretically, the answer should make sense. Like in just some generic problem, like, oh, this is equal to 15.8. But in a word problem, at least have some sense if it worked out or not. Like, oh, it says the runway needs to be 15.8 feet long. Like, that doesn't seem right. The plane is longer than 15 feet. It's not going to work on a 15-foot runway. And then we also have the if button. I got 782. What was the question? How fast is the car going? The car is not going 782 miles per hour. Right? So like word problems you should like because they need to make sense in something of it. I don't know. Students hate fractions too. Was that okay? Now we need to come up with a strategy for solving triangles. Let's take a look at an example. And so I did it wrong. Hang on. Had the wrong thing. That's not even what I wanted. Here is a typical setup. I have a triangle set up generically with the alpha, A, and beta, and B, and C is the hypotenuse. and I've given you 3 pieces of information. So in our standard setup, we've got side A opposite angle alpha, side B opposite angle beta, and hypotenuse C. I'll show them below. And I've given you that alpha is 28 degrees and side B is 6.4 centimeters. So our givens don't need to write it, can't see it. Our givens are the angle alpha, yeah, and side B. We need to come up with a strategy for finding the 3 other parts. Let's take a minute and find one of the other parts. I want you to decide on a strategy. Right now, we haven't talked about what a strategy should be. Let's think about a strategy for finding the other 3 parts. I'm going to pause the video and give you a few minutes to come up with a strategy to find the other 3 parts. So I wonder if that transition is really jarring on the recording. I didn't even know that you could just pause and have it pick up in the same video. But anyway, here we are. So we have this triangle. I've given you, like we agreed, I got to give you 3 pieces of information, and one of those pieces of information has to be a 90-degree angle. So here's a triangle. One of the angles is 90 degrees, and here we have one of the angles is 28 degrees. Angle alpha is 28 degrees, and side B, that is adjacent to the 28, is 6.4 centimeters. Our task is to find the other 3 parts. We need to come up with a strategy for finding those 3 parts. We need to find side C, the hypotenuse, side A, which is opposite the given angle of 28, and angle beta. We need to find side C, side A, and angle beta. I need to know, someone needs to tell me what their first thing they found was, how you found it, and why you picked that to be first. So who wants to tell me what you found first? What'd you find first? You have one? What'd you find? Side A first. Cool. And how did you find it? Cool. So your choice was to find A first. So let's find A first. Great suggestion. I like finding A first. You said you used tangent to do it. So tangent works like tangent of the angle, which is 28 degrees, is opposite over adjacent. Totally works. We're given an angle and we're given 6.4. I have an angle and the side adjacent to that angle. I can find the side opposite using tangent. I can take 2 of the pieces of given information, and we're kind of using the right angle because we're going to say tangent of angle is opposite over adjacent. Great choice. What did you get for A? So let's see, 6.4 times a tangent of 28. 3.4, 3.402, and a bunch of stuff, but 3.4 rounded to the nearest 10, which I didn't specify in this statement of the problem. Great. That's a great place to start. Takes the 2 of the pieces of given information. Says, what can I do with an angle and the side adjacent to that angle? I can find the opposite using tangent. Of the 3 things, you picked one to find, and you picked a method to find it. Is anything that particularly jumped out at you for finding A first? Or is this the first thing that occurred to you? Did you have a reason for picking A? Okay. Great. Good thing to find. It's also first alphabetically, so it makes sense that way. Now I want to not move on from here. Did someone find something else first? Who looked at this? Let's not find A first. Let's pretend we didn't find A first. That's gonna fall. That's gonna fall. Put it sideways. Let's pretend that we didn't find A first. What's something someone found something else first. Not everybody found A first. The angle. So sorry, I just kind of like pointed in the direction and two people were both volunteering. So I kind of like threw a water balloon over there. So someone will answer. You found angle beta first. Great. So another group might be like, oh, let's find beta first. Although let's spell let's right. How did you find beta? You chose to find beta first. How did you find beta first? What'd you do? You did. Some of the angles is 180. Great. In this case, we'll use the sum of the angles is 180. So beta, we'll just take 180 and start subtracting the angles we know. There's a 90-degree angle and the 28-degree angle was given. And what does that leave us for beta? Who else found beta first? Who's going to find beta first? That was pretty popular. What was the reason that you picked beta to find first? Easier. That's great. That's a great answer. All we have to do is subtract, right? Good choice. I like that. All we have to do is subtract. Well, I didn't ask. Who else found A first? Who else found A first? That was a less popular choice. That's fine. Did anybody find C first? One person found C first. See, it's hard when there's a big popular choice, like finding beta first. They're like, oh, did I do something wrong by finding A or C first? How could we find C first? Sorry, you're the only one that did that, man. Use cosine, great, because C is the hypotenuse, 6.4 is adjacent to 28. I love it. Let's find C first. And you said you use the cosine, so the cosine of 28 degrees is adjacent over hypotenuse. Oops, let's see. And so C is going to be 6.4 divided by, I'm going to write it vertically, add space. So the cosine of 28 will be 6.4 divided by C. So if you multiply by C and then divide by the cosine of 28, we get C is 7.2. So the good news is we have choices as to what part we go after first. The bad news is we have choices as to what part we can go after first. The further good news is that there is a best part to find first. The even further good news is all three of these are correct. Whatever occurs to you to do first, that's the thing that you should do first. You've got to find all three anyway. If you can right away see the thing to find first, then you should do that first. Okay? The best thing to go for first is the first thing that occurs. So good news, whatever you can find first is best. There is no perfect approach. Whatever you notice first is the best thing to do because it makes you start doing something. That's the only thing that you ever need to do in math class, something. The best thing to do in math class is something, even if that thing is wrong. You have to do something, else nothing will happen. Any questions? Yeah. So to know which angle you're using, you can pick. Let's suppose that we are in the category of finding beta first, right? So in the category, let's suppose that we found beta first. Now we've got two angles. I got 28 degrees for alpha, and I got beta at 62 degrees. The 6.4, which angle we use depends on how we're going to read the sides that we're given. So that 6.4 is adjacent to the 28, but opposite the 62. So if we have the 62, we can use that. But the 6 point, where in this part we found C by treating the 6.4 as adjacent to 28, the 6.4 is opposite 62. This is where the problem gets more tricky. Not because we have fewer things to do, but because we have more choices. Once we have this 62-degree angle, we can use that. But then we have to be conscious about how things work. So if we want to use the 62 degrees, we look at the 6.4 and we say that is opposite the 62-degree angle. But it's adjacent to the 28-degree angle. So this 6.4 is opposite the 62 and adjacent to the 28. So if we have the 62-degree angle, I would read the 6.4 as being opposite. So if I wanted to find C now, I would say the sine of 62 is 6.4 over C. Or I could say the tangent of 62 is 6.4 over A. So when we use the words opposite and adjacent, that's always relative to one of the acute angles. So we just have to remember what's opposite and what's adjacent for a particular angle. Questions? How's everybody okay? Just math okay, not okay. Just math okay is all of them. And math okay is like, oh, it kind of makes sense, but I have some doubts. Kind of makes sense and have some doubts is the correct answer. Like if you're at the end of a particular day of math class, feel like, oh, I'm still confused by a few things. That's why there's homework. So you can go practice and be unconfused. Does that make sense? We make things, we judge ourselves way too harshly in terms of math. Like I've watched a baseball game. That doesn't make me qualified to go try out for the Giants. But people think that that's how math should work. You come and watch one demonstration of math, and you're like, oh, I could do this. And then you go try to do it. It's like, oh, how come this is difficult? It's the same reason I can't hit major league pitching. All I've done is watch, right? That makes sense? Stop judging yourself so harshly. Why are you guys so mean to yourself? Math teacher version of, why are you hitting yourself? Well, why don't I get this? Like, oh, you've been doing it for a week and you've done like 4 problems. How good are you supposed to be at it? You know what I mean? This is compounded by the fact that you probably had a teacher that got mad when you got stuff wrong. That's like the opposite of how you should act. I don't know if any of you are planning on becoming teachers, but the last thing you should do is get mad when someone gets something wrong. You should be like all happy. You should be like, oh heck, you got that wrong. That's an opportunity to learn some shit. You know what I mean? Also, if you're planning on becoming a teacher, come and talk to me and I will talk to you. I'll just put that right on the table. I will try to talk you out of it. This is especially true if you're like, oh, I think I want to teach in high school. It's like, oh, dude, you need to come talk to me. And I will talk you out of that. Because if I can, then you probably weren't going to make it. If I could just like talk to you for a little bit and you're like, I convince you that you don't want to be a teacher, then I don't, in this current environment, you don't have enough. But if I can't talk you out of it, if I can give you all the reasons to not be a teacher, and you're like, oh no, I'm fucking determined, then you have a chance. By the way, this is a stupid system to run an education system on. Where you have to be just like super determined just to do the bare minimum of the job. That's really dumb. But here we are. You know what I mean? Let's take a break. Let's think about that deep thought for a little while. And then come back and do more triangle stuff.